All right, today we are diving deep into one of the biggest, most mind-bending questions you can possibly ask. It's an idea that really stretches the limits of science, of philosophy, and even how we think about ourselves. We are talking about the multiverse.
So let's just start with the main event, the big question. Is our universe really all there is? For pretty much all of human history, the answer to that was, well, obvious. Of course it is. What else would there be? But modern physics, it's suggesting that reality might be a whole lot stranger. And before we can even begin to answer that, we have to get on the same page about what the universe even means. Okay, so this is absolutely crucial. What we usually call the universe is actually, more precisely, the observable universe. Think of it like a giant bubble with us right in the middle. And the edge of that bubble is just the farthest point from which light has had enough time to reach us since the Big Bang. This is not a physical wall. It's not an edge. It's a horizon, an information horizon. And this one simple idea is the jumping-off point for this entire conversation. This is the perfect analogy for it. Our observable universe is like the small circle of light from a single lantern on a ship out in the middle of a vast, dark ocean. We can only see what's inside that little circle of light. But here's the question. Do we really have any reason to think the ocean just stops right where our light fades out?
So you might be thinking this whole multiverse thing sounds like science fiction. But the idea didn't come from a movie script. It actually comes from physicists trying to solve some of the deepest, most frustrating puzzles about our own universe. You can think of these as clues in a cosmic detective story, things that just don't add up. So let's look at Exhibit A, the horizon problem. When we look out at the oldest light in the universe, that afterglow from the Big Bang, we see something really weird. The temperature on one side of the sky is exactly the same as the temperature on the complete opposite side. But the puzzle is, back when that light was first created, those two spots were way too far apart to have ever touched or mixed or, evened out their temperature. It's like finding two students who were kept in totally separate sealed rooms their whole lives, and they both somehow turned in the exact same answers to a super complex test. You'd have to assume there's something fishy going on, right?
And then we've got Exhibit B, the fine-tuning problem. Just imagine our universe has this cosmic control panel, and on it are these dials for the basic forces of nature. So you've got a dial for gravity, another one for the strong nuclear force, and so on. Well, here's the spooky part. If you were to just nudge any of these dials, by the absolute tiniest, most insignificant amount, the universe as we know it, one with stars and planets and people, just poof, it couldn't exist. So the question is, why? Why is our control panel set to this one impossibly perfect setting that allows for life?
So how in the world do you solve these gigantic cosmic puzzles? Well, this is where the multiverse steps onto the stage. And it's not just one single idea. It's more like a lineup of competing theories, the prime suspects in our cosmic investigation. And this is the key thing to get. The multiverse isn't just some wild fantasy. It's what happens when you follow our other, best-tested theories to their logical conclusions.
Let's start with the simplest version, the one that's the least controversial. It's called the Level 1 Multiverse, or the Patchwork Quilt. It's based on two pretty standard ideas in cosmology. First, that space goes on forever. It's infinite, and all our data points to this being true. And second, that on the biggest scales, stuff, matter, is spread out more or less evenly. Well, if you've got infinite space, but only a limited, finite number of ways you can arrange particles, the math says that eventually those patterns have to repeat.
So, how far would you have to travel to find another bubble of space that is an exact atom-for-atom copy of our observable universe? A copy that includes an identical version of you listening to this right now? Well, that's the number. That is a 1 followed by 10 to the power of 115 zeros. It's a number so ridiculously huge that you could never write it all down. But, and this is the important part, it is a finite number. It's a real distance. Okay, let's level up. Now we get to the Level 2 Multiverse, and this one is a lot more out there. This idea comes directly from cosmic inflation theory, which is our best explanation for that identical temperature problem we talked about. The best way to picture it is like a giant pot of boiling water. So let's start with the pot itself. The pot is this huge, high-energy space called the inflaton field. This is the very stuff that scientists think powered the Big Bang in the first place. Now, the water in this pot, this energy field, isn't just sitting there. It's in a state of eternal inflation. It's constantly boiling and expanding at an insane, hyper-accelerated speed, creating more and more space as it goes. And the theory says this process is basically unstoppable. It just keeps going, forever.
But every so often, a little patch of this field can suddenly stop boiling. It cools down. A bubble forms. All that energy that was making it expand gets dumped into that new bubble. And that energy ignites a hot Big Bang. And, well, that bubble is our universe. And this idea brilliantly solves the fine-tuning problem. Because if you have an infinite number of these bubbles popping into existence, each with its own random dial settings on its control panel, it's not surprising at all that we find ourselves living in one of the rare ones that just happens to have the right settings for life to exist. Where else could we be?
Now for our third suspect, which comes from a totally different branch of physics, quantum mechanics. This is the many worlds interpretation. It says that anytime a quantum event has more than one possible outcome, the universe itself literally splits into different branches to make room for all of them. So that classic idea of Schrödinger's cat being some fuzzy, half-alive, half-dead ghost, that's a total misunderstanding. In this view, there's no fuzziness. There are just two separate, real universes. In Universe A, the cat is 100% alive, and a version of you opens the box and sees a living cat. In Universe B, it's 100% dead, and another identical version of you opens the box and sees a dead cat. Every possibility happens.
Okay, so we've got our lineup of suspects. We have our theories. But you know, a good detective needs more than just theories. They need evidence. So let's open up the evidence locker and see what we've actually got. This is where the wild ideas of theoretical physics slam into the cold, hard wall of reality.
So I need to be completely 100% crystal clear about this. For all the incredible theories, for all the beautiful math, as of right now, there is zero, zilch, nada, zero direct, statistically significant observational evidence that any other universe exists. Full stop.
So what do we have? Well, it's basically a bunch of circumstantial clues and some dead ends. The fact that cosmic inflation theory works so well is a big hint. Scientists actually looked for a bruise in the background radiation of our universe, a possible sign that we bumped into another bubble universe. They found a cold spot that looked promising, but it turned out it probably was just a random fluke. And places like the Large Hadron Collider have searched for over a decade for signs of things like extra dimensions, and they found nothing. And the idea that quantum computers are so powerful because they borrow processing power from other universes, that's a really cool interpretation, but it is not proof.
So here it is, the final scorecard. Let's just lay it all out. For level 1, what we know is our universe looks flat, which fits with it being infinite. What we don't know is if it's truly infinite. For level 2, we know inflation is a great theory and fine-tuning is a real problem. But we have no clue if the eternal bubble-making part is real. And for level 3, we know quantum mechanics is the most successful theory ever, but many worlds is just one way to interpret it. We can't prove the other branches are real. This really helps separate what's solid science from what's still deep in speculative territory. And that brings us to one last thing, a thought experiment to leave you with. Let's forget about cosmology for a second and just think about what the many worlds theory would mean for you. It's called the quantum suicide experiment. Imagine a gun is wired up to a quantum particle. There's a 50-50 chance it fires and a 50-50 chance it just clicks. You put it to your head and you pull the trigger. Now, from the outside, the universe splits. In one branch you die, in the other you live. But your consciousness, your point of view can only continue in the branch where you survive, right? So, if you pull that trigger again and again and again, an infinite number of times, from your own subjective perspective, what is the only thing you will ever hear? The click, every single time. You would seem to be immortal, even as a mountain of your own dead bodies piles up in these other universes you can never see. So the final question is this: if the multiverse is real, what does that mean about who you are in this moment right now?